Hello my warriors, welcome to lecture number 1 of Gauss's law. Like you all know, we have just completed electrostatics part and now onwards I'm going to do Gauss law, its applications, finding the field due to different geometries like rings or sheets, the line charges and shells and spheres and so on and so forth, and then the problems on shells and plates. The reason why we have separated this out is because I want you to actually understand how Gauss law can be applied in electrostatics. So let's get started. Welcome aboard to Pathfinder series, which is meant for all the JEE 2022 aspirants who are going to write the examination next year. And even if you are preparing for NEET, Olympiads or any other such competitive examinations, you are welcome aboard. So this is Shreyas here, your master teacher for physics. Hello Neha, Thalapati, Giri, hello Shreya, Khushub, Saishri, Vigzi, Manki, Sunil, Pratiksha, Munnabai, Chandan, Priyanka, Shreya, Abhishek, we Enthuse, Enthuse FC. I was just reading your comments. Bacha, no matter what the problem is, remember there is always a solution. Okay? So don't worry, you might have faced some difficulty. I know that. I'm going to reply to you on your Instagram account. Do not worry. Just focus over here. Enjoy the session. Learn from the session. Be positive. Stay positive. Trust me, all the minions, all the warriors out here have some or the other problem. Trust me on that. Alright? Some of you do not know that. Some of you know this. Monkey, yes, that's very true, Kirito. Stop being depressed humans. That's how life is. Himanshi, don't worry, bacha. Don't worry. Everybody has problems. See, guys, understand, there is this very interesting story which, Sundar Pichai talks about. I hope you know who is Sundar Pichai. All right. So he talks about something called as the cockroach theory. Do you guys know what's the cockroach theory? Do you guys know what's the cockroach theory? Hello. Acha Sudhir, don't worry, I'll ping you with another link. Don't worry, I will see your comment and reply to that. Yep, no? Okay, thank you PL. So I'll tell you what cockroach theory is. So one day there was, oh my god, Munna Bhai has already put some cockroaches on the chat box. Ew. Okay, so there was a woman dining at a restaurant and she was with her friends, and then they were enjoying their dinner. It was very nice. And then what happened is there was a big cockroach which just started crawling besides their table. And that was not any ordinary cockroach. It was that big flying cockroach. How many of you are scared of flying cockroaches? Type it out in the chat box. How many of you are scared? Let me know. How many of you guys are scared? And if you're not scared, write I'm not scared. If you guys are scared, type I'm scared. All right. Oh no, not 1 kilometer long, but very close. Munnabai is scared. All right. Some of you are scared till some extent. Kirti Haran is scared. All right. Yalini is scared. Okay. So not at all says Akriti. Naman is also not scared. Wow, very good, my warriors. Nia is also not scared. Okay. So good evening, Shreyas Sir student. Okay. Okay. So PL, your house has a lot of it. Wow, what do you keep in your house, man? Okay, so basically the thing is, as soon as that woman saw that cockroach, she shouted, Alec, what the hell is this? She threw that plate. It fell on everybody's faces. She was probably having some nice pasta. The pasta was on everybody's faces. But the woman on the other side, she was very calm. She didn't react. She was very chilled out. So this is basically called as the cockroach theory. The situation is the same, but how you react to that situation is very different. The woman who shouted, screamed and banged the desk and threw that plate, she just created a mess. The cockroach just got scared. The cockroach got scared and ran away. It just flew off. And like, oh, what the hell is wrong with this woman? The other woman, she stayed calm. Nothing happened. She just had her dinner. Nothing happened. So guys, understand, you will have a lot of difficulties, but how you react to those situations is what is going to decide your future. So learn to react well in a very calm, composed manner. All right. So That's me, Shreyas, your master teacher. And if you want to know more about me, you can definitely follow me on my Instagram handle, that's Shreyas_Vedantu. And do not forget to smash the like button if you have loved my story and if you're going to enjoy all these videos. And if you want to show us your support for this channel, the only English medium channel, do not forget to hit the like button and the subscribe button. Do that, guys, because I ask you every time, because I know a lot of you are going to be new users. Some of you are going to probably come back after a long time. You might have forgotten to subscribe to our channel. All right, so just do that. And also do not forget to share our channel name or recommend our channel to all your friends out there. There is some interesting news. Khushbu is after a long time. Yes, see, I just told that. Oh yes, Ruchi, well, are you going to get your word question analysis? I doubt about that. Are you scared? Okay, Neha, you have asked a very interesting question. Are you scared? Well, I'll answer that question in the next Coffee with Shreyas question. Coffee with Shreyas session. Okay, so you can keep a list of all such questions, and then probably I'm going to answer all of that. Till that time, it's a suspense. So some interesting news coming up here. KVPY results are out, and these are our Vedantu students who have got really amazing ranks. In fact, 54 Vedantu students have qualified for KVPY examination. That's a big number considering very few students get qualified for KVPY throughout India. Out of that, 54 are from Vedantu, rank 78, 72 and 221 from Vedantu. That's an amazing feat, guys. And I mean, just if you think about it, there is still few months more to go and for the KVPY SX examination next year, because most of you are now in 12th standard. So guys, my advice to all of you is feel or get that motivation from all these toppers. Do not think that you cannot do it. Just start acting from now onwards. You have to, yes, plan for it. In fact, I gave you guys a 1-year plan. Similarly, keep these ambitions. Yes, by October, I want to do this. I want to crack KVPY exam. Yes, I want to do this. I want to show, my parents, my relatives, my teachers, yes, I can do that. So start planning, start acting from now on. The time is never enough. Remember, no matter how early you start. So the earlier you start, the better it is. Yes. Okay. So what is KVPY? Jaya, KVPY is nothing but Kishore Vaigyanik Pariksha. Basically, it's an examination, okay, for getting into the science stream like IISc and then ISER and all that. They take admission through KVPY and they also give you scholarship if you qualify the second round, that is the interview round. Okay, so that's what it is. Okay, yes, Khushbu, why not? I remember most of the names which I have seen at least few number of times. I definitely end up remembering. Yep, Vijay Kumar, Thilapati. Oh my God, Thilapati, you changed your, Vijay Kumar, you changed your name to Thalapati. Why? Why would you do that? So guys, those of you who have forgotten to subscribe, let me just remind you the batches for our pro subscription, which will include live classes, replays, tests, assignments, class teachers, English and Hindi medium batches, micro courses, all under one roof, plus KVPY preparation is also going to happen in this batch. There is a KVPY batch starting very soon, all right, inside the pro subscription, again free of cost. All of this, all right, the batches are starting in this week and the next week. So guys, do not delay, because the earlier you start, the better it is, because the earlier you start, the sooner your portions will get ended. So if you start later on, obviously the portions will be pushed slightly up there. So why delayed? Because you can see the pandemic, the way it is turning out. So you have all the three options. I'll be explaining you about the light, classic and the plus version. So the light one is basically the basic course without doubt solving, except all the other things like micro courses, tests, assignments, Tattva module, hard copy, soft copy, all this you will get. The only thing additional you get in classic is the doubt solving through the mobile app, and in the plus you will get the personal mentor. Now what is all this? I'll explain you at the end of the class. Let's first start with our today's topic, which is electric flux. Let's get going. We do not know whether KVPY will happen early or late this year. It's too early to tell because we'll have to wait for it. But what we can do is we can act and we can start preparing. That's the only thing in our hand. Okay, so remember this. Thank you, Chandan Malik. Love you too. Thank you, Abhishek. I know the times are harsh and we are always going to be there with you, and this Pathfinder is going to be there till the end. We are going to be there for JEE 2022, 2023, 2024, all the time. All right, so let's get going. Okay. Yes, so now onwards, remember all my timings are at 7:30. 7:30 evening is when you're going to find me on Enthuse channel. Now let's talk about flux. Now the meaning of flux is nothing but flow of something. Okay, so the meaning of flux is basically flow of something. Now when I say electric flux, it means the flow of electric field lines. But through what? Through a surface. You are going to also study magnetic flux in the next chapter and so on and so forth. So for now, understand, when you have some field lines and there is an imaginary or an actual surface, remember this, if there is an imaginary or an actual surface and these field lines pierce through it, then I will say that there is some electric flux piercing through that area. Okay, so there is some electric flux piercing through an area only when it pierces inside of it, the electric field lines. So they are flowing through that area. So that flow of electric field lines is called as electric flux. What is the symbol for that? The symbol for that is phi. So phi is the symbol for electric flux. Like you can see, electric field lines are piercing through this actual or imaginary area. It's something like wavefronts, Aditya, but understand, Aditya, wavefronts are something else. Wavefronts are basically those surfaces where the waves reach simultaneously. Those are wavefronts, but these are any random surface, anything. You can imagine it imaginary wise, or it could be an actual surface. Yes, Vimla, I teach the 12th classes in Vedantu. I am right now teaching in the toppers batch, plus I'll be teaching in many of the micro courses as well. Okay, now what does this flux depend on? So guys, let me also tell you, if you have any doubt apart from academic during the class, just so that our flow of the class does not get disturbed, please write all your doubts or comments below the video after the session is over. Because right now you won't be able to comment anything on this channel, on this video. So write it after the video ends, or you can write it in the just previous video. So I would request you to please write it down after the video ends. Collect all your doubts and keep it somewhere in a notebook. Now what does the flux depend on? So think of flux like field lines or wind which blows through a window. If I tell you the wind is like field lines and the window is like that area, obviously more the wind, more the flux. More the wind, more the flux. Bigger the window, bigger the flux, because more wind will flow inside. I hope this makes sense. So understand, electric flux depends on number one, electric field. Why? Because if electric field is strong, then what will happen? If the field is stronger, they will be closely packed. Those electric field lines will come close to each other. There will be more field lines per unit area, more number of lines. And because the density of field lines is higher, the number of lines which will actually pass will be higher, and that's why more flux will pass through the surface. I hope this is clear. Yes, I hope this is clear. Yeah. So more the field lines through an area, more is the flux. That's what the first point is. So flux depends on how many field lines pass through an area. So more the field, more is the flux. Second thing that the flux depends on is obviously the surface area. Now, if the area is small or big, what will happen? You will collect more field lines or you will discard few field lines. So understand, if you have a small area, then some of the field lines might not pierce it. It might go from the side. So flux will be smaller. But if you take a large area, then what will happen? Then you will accumulate more field lines cutting through that area. So the flux will be higher. I hope this is clear. Yes, so the number of field lines passing is less if the area is less, so the flux is also small. If surface area is more, then the flux is also more. All the warriors are understanding this? And there is a third thing, the flux depends on one more thing, guys. For the same area, for the same field, the flux can be different for different what? What is that third thing which also affects flux? There is one more thing for which the flux will change. Can you type it out? Think, if there is an area, there is a field, You change the area, flux changes. You change the field, flux changes. There is one more thing. What is that thing? I think Kirito has answered it. Debbie, if medium changes, field will automatically change. So that is the first pointer, which is field. So yes, the answer is angle, Minion Aarti. Yes, correcto. So if you change the angle between the field and that area, so right now the field lines are passing like this. If you change the area like this, then some of the field lines might miss that area. If you make the area like this, the field lines will not even pierce it, they will just graze through it. So the angle between the field and the area also decides what is the flux. So if the flux, if the field and if the field lines and the area, are arranged in such a way that maximum field lines pass through it, then the flux is good. But if you change the angle, some of the field lines might go from the top, from bottom, and you might miss some of the field lines, so flux will reduce. So angle is the third thing. Yep. So keep this in mind. Now we are going to talk about the formula as well. So look at these two diagrams. Look at these two diagrams, guys, and I want you guys to answer this. See, if you look at this green area number 2 and if you look at this green area number 1, which green surface has more flux? Think about it. Yes, Abhishek, we are going to define area as a vector quantity in a bit. Yep, in a bit. Which one has more flux, guys? Come on, answer this question. Excelente. Excelente. Very good. Minion. Aarti, why 3? No, it's 2. There is no third surface. Okay, so it's the second surface. Very good. You can see some of the field lines are being missed out over here. So we just told the flux completely depends on number of field lines, okay, piercing through an area. Okay, so this is very important line, and the flux is given by, now the basic formula is going to be field multiplied by area. So it is just going to be field multiplied by area, but there will be one more term which will come over here, which will be dependent on the angle, because more the field, more the flux, more the area, more the flux, but there has to be one more term, and that will be basically, you will see in some time I'll come with that angle term over here. But for now, flux is field into area into something which depends on angle. I'll come to what that is in the next slide. For now, let's solve some basic questions. Okay? Yep. Let's do this. In which of the following cases the flux is 0? Try to answer this question. Which of the following cases the flux through the surface is 0? Field lines are parallel to the surface. Field lines are perpendicular to the surface. A surface perpendicular to uniformly charged sheet. A spherical surface enclosing a point charge. More than one option may be correct. Be careful, guys. My warriors, be careful. More than one option is correct. Thank you, Thanusha, Somu. Thank you so much. Guys, if you are new to the channel or if you have forgotten to hit the subscribe button, first of all, hit the subscribe button and do not forget to shower your love by smashing that like button down there. Okay, now you have changed your answers to A and D. Is it A and D? Okay, let's figure this out. Field lines are parallel to the surface. Let's do this. First of all, let's say this is my surface. Now in the first situation, the field lines are parallel to the surface. Guys, are they piercing it? Are the field lines piercing it? No, right? So that means the flux is 0. So the first option is correct. I hope this is clear. The field lines are parallel. They are not piercing through it. They should pierce. They should make a hole. Yep, they are not making it. Field lines are perpendicular to the surface. That means the field lines are like this. Oh, they are definitely piercing the surface. Can you see that? The perpendicular ones are actually piercing it, and hence the flux in this case is definitely not 0. So I will not mark it because the question says through which all surfaces the flux is 0. And now Next one, a surface perpendicular to uniformly charged sheet. Now let's look at this. There is a charge sheet. Okay, there is a charge sheet, guys. So these are the charges. Okay, these are the charges. Now how will the field lines look like? The field lines will look something like this. I hope you know that, because it's a charge sheet, right? The field lines will be parallel. This will be in that direction. All right, if this is the sheet, the field lines will be in this direction, like this. I hope this is clear. The field lines will be like this, like this, like this, like this, like this. All uniform, all coming out of the sheet. Now think, if you draw a surface, perpendicular to the sheet, if you draw a surface which is perpendicular to the sheet, look at that. This surface is actually perpendicular to the sheet, guys. So are the field lines piercing through the surface? Look at that red surface. Look at that red surface. Are the field lines piercing through it? No, right? So the flux is 0 and hence this option is correct. Yep, I hope this is clear. And the last one, a spherical surface enclosing a point charge. If you take a point charge, let's say like this, and you take a spherical surface enclosing the point charge. Guys, I think this one is very obvious. From the point charge, the field lines will come out. You can see the flux is piercing everywhere. Flux is piercing this surface everywhere. So hence the flux is not 0. So the correct answers are A and C, like you can see over here. Yep. Is that clear? Beautiful question which explains you the concept of flux without any formulas. Okay, so that's the answer, guys, A and C. Let's do one more question up on your screen now. Question is, compare the flux in the following diagrams. I'll explain you what the diagram is. Glad you loved the question. Vikram, Monkey, Neha, very good. Yes. No problem, Sai Sushant, happens. Yes, Andrew, very good. Chennai is correct. Okay. So, there is one sphere, another sphere, and a cube. Sphere, smaller one, a bigger cube. Which surface will have more flux because of the field lines coming from this positive charge? Come on. Phi1 more than Phi2 more than Phi3, Phi3 more than Phi2 more than Phi1, Phi3 equal to Phi2 is equal to Phi1, Phi3 more than Phi2 equal to Phi1. I don't know. 3, 2, 1, 3 more than 2 more than 1, 1 more than 2 more than 3, 1 equal to 2 equal to 3, 1 more than 2 less than 3. I don't know. What is the answer? Come on. Hi Raghav, welcome aboard. Okay, so let's have a look. Okay, 3, 2, 1, 1, 2, 3. Come on, come on. Let's do this. Okay. First of all, if I draw the field lines, it will look something like this. It will look something like this. Okay, it will go like this. Okay. There will be many more such field lines, but I'm just drawing a few of them. Now answer this. How many field lines, according to the way I have drawn, cross surface 1? Count it. How many field lines cross surface 1? Count it, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9. Check it out. Okay. So monkey was very quick. Now also count how many field lines cross surface number 2. How many field lines cross surface number 2? And lastly, also count how many field lines cross the cuboid surface. I hope you see that the answer is 9. I hope you see the answer is 9 for everyone. Alright, that means, guys, try to recollect the definition of flux. Flux is dependent completely on the number of lines which pierce. If the number of lines are the same line which pierces 1 will pierce 2 and will pierce 3. That means the flux of 1, 2 and 3 are all the same. Yep. Quick monkey. I hope this is clear. Yes, 1 is equal to 2 is equal to 3. Yes, Santosh. Okay. Yes, Andrew. Yep. So Abhishek, it's not 1 is equal to 2 plus 3. Okay, it is 1 is equal to 2 is equal to 3. Yep. Correcto. I hope everybody has understood this. Vishal, this is not a Hindi channel. This is an English channel. There is a separate JEE Hindi channel. This is a channel meant for all the English medium students who want to learn in English. Alright, so that's a channel dedicated for them. Okay, so that's the answer, guys, and hence the answer is phi 1, phi 2, phi 3 are all equal. Can you solve it by solid angle concept? Aditya, you don't need solid angle concept. Unnecessarily, institutes waste their time teaching solid angle, then students don't understand what the hell is solid angle. It creates more confusion than clarity. So that's why don't use it. Okay, so let's get going. No problem, Abhishek, happens, typo error, I guess. Now, if the field is at an angle, okay, to the surface, so to figure out what is the flux, here is what I'm going to do. Now look at that red color surface, guys. Look at that red color surface. Now think about it. If I draw a perpendicular, what is this n hat? This is unit vector perpendicular to the surface. What is it? It is a unit vector perpendicular to the surface. Think and tell me whether E cos theta or E sin theta causes flux. Which one causes flux? Who is responsible for flux? E cos or E sin? Come on, think about it. Is it E cos or E sin? Come on, think about it. Is it E cos or is it E sin? Come on, E cos or E sin? E cos is like this, E sin is like that. Yep, E cos theta. Yep. So, Chandan, flux will never stop, it will go till infinity, remember that. Flux will never stop unless you find a negative charge. So, E cos theta causes flux. So, that gives us the formula. Okay, now I will define something called as an area vector. Now, area vector, okay, area vector is nothing but, if I have some area and I tell you the area is, okay, the area is, let's say 10 I cap. The area is 10 I cap. If I tell you the area vector says it, alright, it is 10 I cap. What it means, you draw a vector in the I cap direction. Now you show an area perpendicular to I cap. This magnitude is 10 meters square. This magnitude is 10 meters square. That's the meaning of area vector. So it's a vector which is perpendicular to the area. So if this is my area, so this pen represents area vector. If I hold the area like this, that is the area vector. It is always perpendicular to the area. I define it like that. Remember that. Okay. I hope this is clear. So now understand this. Similarly, if I tell you guys, the area vector is 3i cap plus 4j cap. What does it mean? So 3i plus 4j will be like this. This is the area vector 3i cap plus 4j cap. Okay, so if you draw a vector which is perpendicular to that, this one, how much will be the magnitude? Okay, just find the magnitude of this. What is the magnitude of this? It will be nothing but root of 3 square plus 4 square. 3 square plus 4 square, 25. Root of 25, 5. So this area is 5 meters square, but the direction is in 3i cap plus 4j cap. The direction is in 3i cap plus 4j cap. That's what it says. Yes, Sunita Mishra, I'm going to complete the entire syllabus. That's what the Pathfinder series is all about. Yep, I hope this is understood, guys. So that's an area vector which gives us a clear-cut definition and orientation and magnitude of how the area is. Imagine if I had to tell you, oh, I have an area. Okay, I have an area which is pointing, it's like this. Imagine having to describe that area. It's so difficult, right? It's there, it's tilted at 30 degrees with this axis, it is tilted at 29 degrees with this angle. Arey yaar, it's so difficult, yaar. So that's why make it in vector notation, it becomes very easy. So that's what it is. Yep. So having said that, how do we now write flux? Flux is electric field into area vector into cos theta. Why cos theta? Because only E cos theta, like I was saying before, only E and cos theta are responsible for the flux. into the area, which is S or A, whichever symbol you would like to use. So Es cos theta is nothing but flux. But like you remember guys, if you have a vector A and B, and if you multiply them like this, AB cos theta, then it can be written down as A vector dot B vector. That was the definition of dot product. So that's why I've written it down as E dot S. E dot S. I hope this is clear. Yes, Vijay KV, you can definitely understand that. Understand using these lectures, even though you are preparing for JEE 2021. It's okay, perfectly fine, bacha. Okay, so E dot S. Everyone fine till here? Why don't we consider area as always a vector? Abhishek, you can do that for pressure also. You can do that. No harm in that. Okay. The problem with pressure is, you know, the force of the pressure is always perpendicular, so it is always understood. So that's why we do not do that, because of, you know, more like, you know, forces are always perpendicular to the area, not at some other angle. That's the only reason. Okay. Now, remember what is theta? Theta is the angle between field and area vector. What is area vector? Area vector is a perpendicular vector to the surface area. I just told you. And E is the electric field. Clearo? Very good. Now, you might be wondering, sir, every time the situation will not be good. This time the area was flat. But what if the area is curved? What if the field lines are not uniform? What if the field is randomly oriented in different ways? So let's talk about that. For non-uniform field on curved surfaces. Non-uniform field on curved surfaces. Yes, basically Vikram, it's a normal vector. Correct. Area vector is very similar to normal vector, because if you take a surface and you draw perpendicular, that's a normal, that's the direction of area vector. Perfecto. Yes. Now, the only thing when you have a curved surface is that the problem is there are many small flat surfaces. You can divide this big curved surface into small flat surfaces like this, and at each point the field might be in different directions. Correct? The field might be in different directions. So the total flux is the sum of the flux through what? The small areas which have been divided. All right, the small areas. The entire curved surface has been divided into small areas. Yes, Aswari, you can ask it. Yep, correct, Abhishek. Yep. Now, whenever you add, sum, integrate, yes, that's what integration is. So basically, you are going to integrate it. So that's what this is all about, guys. So whenever you want to find the total flux, okay, you are going to integrate it, but instead of S, you have ds. What is ds? It's a small area. It's a small area. This one, this is that small area. So E dot ds will give you that small flux. Integration, that integration symbol stands for sum, or basically addition. Understand that. That's why you are having integral E dot ds. Understood, everyone? I hope this is clear. I hope this is clear. Sir, what for non-uniform formula? They put a circle. We are going to come to that, Munna bhai. Hold on. Infinitely small area. Yes, yes. Very small area. Infinitely small area. Yeah. And if you want to write it in the normal form, without the dot vector, without the dot symbol, then you write E ds cos theta. As simple as that. Very good. Now, yep. Now that you guys have understood this, yeah, this is for is the non-uniform field. Oh, I forgot to also tell you about this, that flux is a scalar quantity. Remember, this is a dot product, and just like in work, remember work was force dot displacement. These two were vectors, but the resultant, the multiplication was a scalar. Same way, the flux is a dot product of field and area. This flux is a scalar quantity. What is the unit? Field's unit. What is the unit of field? Newton per coulomb. Newton per coulomb is the unit of field, right? It was Newton per coulomb. And the unit of area, obviously it is meter square. So Newton meter square per coulomb. As simple as that. Can I write delta in place of d, Vishal? Yes, you can write it, but then it will not be infinitely small and the answer won't be accurate. When I write delta, it means it's a little bit bigger area, not infinitely small. Okay? So when I write d, it means it is infinitely small. Understand that. Now, product of two vectors can be a scalar, can be a vector. Remember, when I have two vectors A and B, if I put a dot, I will get a scalar, correct? And if I put a cross, then I will get a vector. That's the symbolic way of multiplying vectors, and that's how you get it. That was scalar product and dot product. Now, let's concentrate on a closed surface. Closed surface. Now, what is the meaning of closed surface? See guys, have you ever done some shopping and you would have carried those shopping bags? Alright, you would have carried those shopping bags in your hand. Something it looks like this. Okay, this is a shopping bag example. Okay, and yep, this is a shopping bag. Now, it's closed, but understand this part is open. You can see this part is open, like air can enter inside, anything can enter inside. This is an open surface in a way. There is a closed part below. As such, this is not a completely closed surface. But if I staple it, okay, and maybe, I don't know, I do something like this, I staple it, now it becomes a closed surface. Similarly, your backpack, when you open the zip, what kind of surface is it? What kind of surface is it? It is an open surface. Now, when you close the zip, what kind of surface it is? It will become a closed surface. Correcto. So Manan, your doubt, you can ask it after the class in the comment section or post your doubt on my Instagram handle Shreyas_Vedantu. I'll try and answer it over there. Okay? Cool. Post it below in the comment section. So guys, same way a closed surface has a lot of importance because we are learning Gauss's law today, and that's why I'm talking about the closed surface flux. You will see the importance in some time when I talk about Gauss law. Now this sphere is a closed surface. Now again, if I want to find the flux through the closed surface, again I'm going to divide it into small areas. This will be my dA vector. Okay, so this is my area vector dA, and the field over there might be in this direction. This is the field over there. So the small flux, all right, the flux through the element will be E vector dot dA vector. Through that small element will be E dot dA. So the flux through the closed surface, will be integral E dot dA. But since it is closed, you put a symbol like this, which is called as a closed surface integral. That is just symbolic to tell the person who is going to perform the mathematics, or the person who is going to solve the problem, that hey, hold on, be careful. You have to integrate for the entire surface. Do not leave any patch over here. You have to cover all the sides, all the surfaces of that figure. That's a symbolic mathematical way of writing this. That's all. I hope this is clear. Yep. Yes. So Vijay, I will always go from the basics. Sorry if you are finding it slow. I have to go like this because this is a Pathfinder series. This is a long-term batch. This is not a one-shot lecture for 12th standard students. So understand, some people are dependent completely on Enthuse. Okay, they cannot afford subscription, they cannot afford coaching. Some of them are in remote parts of the country. They lack basic education, they lack that infrastructure, good teachers. So they want to study in English. That's why they are dependent on us. So I need to make sure that every kid, tries their best to understand whatever I am saying. Okay, cool. Let's get going. So cyclic integral E dot ds. So let's solve problems now coming up on your screen. find the value of the flux through this complete cube. You can see there is a cube, I hope you can see, which is placed in a uniform field E naught I cap. What is the meaning of E naught I cap? E naught is the magnitude, direction is along this side. What is the total flux through this cube, guys? Come on, try to answer this. Okay, come on. Let's see how many of you do this. Okay, come on. Some of you are saying C, some of you are saying A, some of you are saying none of these. Okay, come on, let's see. Well, I'll tell you what, the answer is actually 0. Now you might be wondering, sir, what nonsense is this? Come on, field lines are piercing through that cube. I can clearly see, sir, the field lines are piercing through the cube. You can see the field lines are piercing through the cube. How can you say the flux is 0? So guys, now there is a sign convention to flux. There is a sign convention to flux. I'll tell you what the sign convention is. So, I'll tell you what the sign convention is. Going back over here. Now remember this, very, very important. None of you probably thought about this, that, you know, when you have an area and when you draw a perpendicular, okay, when you draw a perpendicular, which side do you take the area vector? Because one can take the area vector this side or you can take it this side. Both are okay because both of them are perpendicular to this area. So area vector has two options, either that way or this way, because a perpendicular can be this way or that way for a surface area. So now let me tell you, there is a convention. You cannot choose any random thing if the surface is closed. If the surface is closed, understand, you have to take the area vector outside. That's by convention, because there will be no confusion, because obviously our world is full of all kinds of crooks. One person will be like, no, I'll take it this way. Other person will be like, I'll take it this way. Other person will be like, I will take both ways. Other person will be like, oh, to hell with both, all of you, I'm not doing this problem only. So we need a convention, and the convention is, you know, outwards. Just like you have traffic rules, like you have to drive on the left hand side of the road, correct? Same way, it's like a convention. So area vector has to be taken outside. So all the field lines which pierce out, like you can see over here, they are coming outwards. Can you see that? The flux, the field lines are coming outwards. The flux because of them will be positive or negative. The flux because of them will be positive or negative. If the field lines are coming out, what do you think, guys? Think about it. Yes, it will be positive. And if the field lines are inwards, then the flux is negative. Keep this in mind. Outwards positive, inwards negative. That's it. So basically, coming to this problem, can you quickly tell me, on the left side, is the flux positive or negative? On the left side, the field lines are piercing through the cube, guys. Is the flux positive or negative? Come on, guys, answer the question. Very good, it is negative. And on the right side, is the flux positive or negative? Come on, guys, answer the question. Is the flux positive or negative? Think about it. Is the flux positive or negative? Excellent, positive. Now, is the amount of lines through the left surface equal to the amount of lines through the right surface? Yes or no? Is the amount of field lines through the left surface equal to the number of lines piercing through the right surface? Yes or no? Same. So total flux will be 0. Understanding this? Beautiful, beautiful, excellent. Ansh, your 12th starts with me. You are here with me. Trust me, I'm here to take care of all of you. Great. Now I'll tell you one more thing. I'll ask you one more thing, guys. Let's not stop there. I'm going to ask you one more thing. What is the flux through this front surface? Through the front surface, AEHD, the field lines are going like that. Imagine the surface is like this. What is the flux through the red surface that I have shaded? Excellent, Guru Mantra, Priyanka, Anjali, Chandan, Shivangi, Jimwell. I don't know, you said boo mo. What is bobo mo? Are you a cow? Okay, 0. And the same thing is also true for the top, behind and bottom surface. Because the field lines are not piercing through it. They are parallel. They are grazing through it. Choo ke nikal gaya. It just grazed through you. It did not pierce you. The arrow just went past by you. It did not pierce you, guys. Yes. So the answer is 0 anyways. Let's do another question. Okay. And here it is. Now, same cube. The left side is at a distance L. The left side is at a distance L. The cube side is A. The field is E naught X I cap. So guys, understand, since this X is there, that means it is non-uniform. It's non-uniform. So as you move towards right side, as X increases, your field also increases. As you go more towards the right, the field increases, like you can see in this diagram. As one moves from left to right, the field strength increases, but it is always towards x-axis. It's always towards x-axis. Question is, what is the net flux through the cube? Hi Ansh, welcome aboard. No problem, Shreyas. You missed a lot. I'm telling you, you will have to rewind back. Okay? So let's see how many of you can solve this question. Beautiful question. Yep, Ansh, no problem. Join in. You will understand the concept as I explain. First, try it out. Hint: there will be 4 surfaces through which flux will not pass. There will be 4 surfaces through which flux will not pierce only. Which are those 4 surfaces? Can you label them? Can you type it out? Think about it. Only 2 surfaces are there, and through one it is positive, through the other it is negative. So you can solve it. That is your hint. 4 surfaces through which flux will not pass. Only through 2 surfaces it will pass. So think about it. Think about it. What should be the answer? Come on, all my warriors. So I'll tell you what you should do. First of all, this surface, front and bottom. That means, I'll write it over here. Front, back, top and bottom. Alright, through all these surfaces the flux is 0 because they will just graze through it. But through the left side, well, let's think about it. Through the flux through the left side will be the field multiplied by area vector, or basically field multiplied by area. But hold on, shouldn't it be negative because the field lines are entering inside? So first of all, I'll put a minus sign. So field on this surface multiplied by area of that surface. Gaurav, hello, I'm not ignoring you. Hold on, I'm just looking here. Please don't spam. Okay. Now, what is the field over here? Look, think guys. Think in 3D. Think over here, x is 0. At this surface, what is the value of x? On BCDA surface, what is the value of x? On BCDA surface, what is the value of x? The value of x is L. So guys, the field is E naught into L. I hope you guys understood this. Exactly. Now, what is the area of this surface? Oh, that's area of the square, which is nothing but a square. That's the flux on the left side. Cool. Now, going similarly to the right side, let's think about the right flux. Okay, I just shaded it. So flux on the right side will be, hold on, first of all, the field is coming out. The field is coming out, so it must be positive. Done. Next, it will be field again multiplied by area. So what is the field value? The field will be careful, the value of x is L plus A, because look at this face, it is at a distance of L plus A. So it will be E naught into L plus A, guys. E naught into L plus A and into A square. Now you just add both of them. Just add both of them. What are you going to get? Because you want to find the total flux, right? Total flux. So you are going to get E naught, okay, L A square plus E naught A square minus E naught, all right, E naught L A square. You can clearly see who all get cancelled. E naught L A square, E naught L A square. So the only thing which remains is this guy, so which is E naught A cube. That's it. That's the answer. Understood? So Naveen, in a week for now we'll have 2 classes of 12th standard. Okay? So in a week at least 2 classes of 12th standard. Yep. I hope this is clear. So Ansh, I'll be coming usually on Tuesday, Wednesday or Tuesday, Thursday for 12th. Okay? Other days, one is for 11th and another 2 days are for the passing out 12th standard students, okay, who are going to write the examination this year. Yeah, so that's the schedule roughly, okay. And you can also please log in and subscribe to our Telegram channel, where we'll keep posting you the daily schedule so that you do not miss the classes. Let's try and do another question. Precisely it was given, it was a cube, okay. Why can't it be D option, Mala Mohan? Because we just got it as B option, and I just got for the previous one, it was E naught A cube. That's why it is not E naught A cube by 2. Okay, I hope this is clear. Yeah. Is the number of field lines entering and exiting the same? No, Abhishek. Why? Because this was non-uniform field. So understand, the field lines will change in density. Few field lines will come in, but as they come out, there will be more number of field lines. I hope this is clear. Okay, there will be different number of field lines. Okay, let's do this question. Let's do this question. Find the flux through all the surfaces. All the surfaces. Okay. First, let's do this, guys. Come on, come on, come on, come on. You're going to understand this. What is the flux through the triangle? Here or over here? Come on. What is the flux through the triangles out there? Answer the question quickly. The field lines come from behind the prism and go like that. What is the flux through the triangle? Answer the question, guys. What do you guys say? I feel it is very simple. Very good, Munna bhai. Yes, 0. Very good. It is 0. In fact, it's not just 0 there. Even at the bottom surface, it will be 0, because it is not piercing. It is just passing over it. It's just passing over it. Correcto. Next, let's look at this surface over here. Let's look at the surface behind. The flux behind, all right, behind will be field. What is the field? 100 multiplied by area. What is the area? 10 into 30, but that is in centimeter. So convert it into meter. Convert it into meter square. So this will be 10 to the power 3. This will be, yes, is this 3? Check this out. Is it 3? Yup. Check this out. Is it 3? Now, should I put plus or minus? Think about it. Should I put plus or minus? Because the field lines are entering in, not going out. So hence the answer is negative. Keep this in mind. Yep, negative. Excellent. Now, through this surface, the slanting surface, now you might be wondering, sir, we will have to take the angle. Don't have to take the angle. Guys, think about it closely. Won't all the field lines which pass through the red surface also have to pass through the green surface? Those of you did not get it, I'll just draw it here. All the field lines which pass through the red surface will have to pass through the green surface, yes or no? So hence, isn't the answer obvious for this one? Yep, the flux through that slanting surface will be just plus 3. That's it. Plus 3. Beautiful. So that's how you solve flux related questions. Okay. So guys, let me also tell you, There are lots of micro courses in 12th standard and 11th standard. So even if you are a 12th standard student, you can access all the topic wise courses, be it optics, electromagnetism. Let's say you are in a batch and you still want to learn again through some other teacher, you can still join the micro courses absolutely free of cost. There are not just chapter wise micro courses, but there are also micro courses on H.C. Verma, Erode book discussion, previous year questions, then numerical problem solving, derivation micro course. All these kind of micro courses are there. Some of them even I have taught, Shimon sir has taught, and lot of teachers that you see on YouTube are there. So guys, do not forget, when you join pro subscription, you get all of these micro courses for free. Let's go to Gauss's law now. Yes, Chandan, we're going to come to optics very soon. I mean, after magnetism, we are going to come to that as well. Why was the angle given, Munna bhai? Confuse you. ऐसे ही मजे लेने के लिए. Okay, thank you, Shreyas. Happy Civil Services Day to you. And I forgot to tell you all, Happy Ram Navami, guys. Happy Ram Navami. I hope you had a great time at home as well. Okay, so let's talk about Gauss's law. Now, what is Gauss's law? If you have some charges, if you have, let's say, a positive charge, there will be some field line coming out of it, correct? There will be some flux through that surface, yes or no? Yes or no? Now, if I move this charge somewhere else, if I move this charge somewhere else, inside only, through this closed surface, this is a closed surface, then the number of field lines which will be coming out of it will be the same, just that the field lines which were cutting here will now cut somewhere else. The field lines which were cutting here will now cut somewhere else. But the total flux will remain same, yes or no? Think about it. No matter where this charge is inside, the field lines will shift, but they will have to cut through the closed surface. So the flux remains the same. Cool? Okay. Now imagine this. If there is a charge here, there are some field lines coming out of it. There are some field lines coming out of it. If I add more charges, what will happen? More flux will come. There will be more flux through it. Yes or no? So yes, if I increase the charge here, then the flux coming out of the surface will also increase. Beautiful. Now think about it. If there is a charge here and these are the field lines coming out of it like this. These are the field lines coming out of it like this. I place another charge outside. I place another charge outside. Because of that, what will happen, guys? This positive charge, the field lines will bend. In fact, it will end up bending these field lines also. These red field lines which are there, they will also bend. They will go like this. They will go like this. I hope you can visualize this. They will bend because there are some charges present outside, they will bend. But understand, the field line which was cutting here will now cut somewhere else. The field line which was cutting here will now cut somewhere else. But the total number of field lines will still remain the same. The total number of field lines will still remain the same. I hope you can see that. So, did this external charge change the flux through the surface? Think about it. Did the external charge change the flux through the surface? No, because this charge was creating some flux, one shown in red. Because of this charge, they bent, but the total flux remains the same. So, this brings us to Gauss's law. It says the total flux through what? Closed surface. Through a closed surface. It's directly proportional to the charge which is inside of it. The charge which is inside of it, not what is there outside. That's what Gauss's law says. I hope everybody is understanding this. more the charge inside, more the flux. Doesn't matter where the charge is, but it is directly proportional to the charge inside. And if it is outside, doesn't matter. If I take a charge here, the field lines will just pierce and go in. That's it. Look at the flux. What is coming in is going out. Nothing is there inside. So flux is zero. So charge present outside will not create any flux. Understand that. Net flux. It will be creating flux, but whatever is coming in will be going out. So total flux will be zero. So charge present inside. So guys, what is the total flux through a closed surface? Cyclic integral E vector dot dA vector. Correct? That was the total flux through a closed surface. Inside charge. So I'll put it as Q in. Instead of proportionality, I'll put equality, and that constant of proportionality is epsilon naught. The constant of proportionality is 1 by epsilon naught. So that is nothing but Gauss's law. What is this? These are the charges which are present inside the surface. This is a closed surface. Closed surface. Understand that. So this is Q in. All the charges which are present inside by epsilon naught is total integral over here, which is also the flux through the closed surface. Okay, I hope this is clear. So I'll just put it up over here on the next slide. The total flux linked to a closed surface is equal to 1 by epsilon naught times the total charge inside the closed surface. So net flux is Q in by epsilon naught, and the net flux is also written down as cyclic integral E vector dot dA vector. Okay. The net flux is because of the charges inside only. So which are the charges inside? Q1, Q2 or Q3? No, Gauss's law is valid for fields produced by stationary charges only. Okay, Tarun? Okay. So guys, think about it. So is Q1 and Q2 and Q3, all right? Which of them are interior charges, enclosed charges? Come on, think about it. Only Q1 and Q2. Very good. Q3 is an external charge. The flux will not depend on it. Let's start solving some problems. Come on. The figure shows 4 or 5 charges over here, and you know they are all charged with Q1, Q2, Q3, etc. There is a surface which is drawn. There is a surface S which is drawn. What is the net flux through the surface? Come on, think about it. What is the net flux through the surface? Come on, easy question, straightforward question, warm up question to build up the mood. Come on guys, let's get going quickly. Mini Pahul, oh my god, such a long time. Join back, bacha, where were you? Don't disappear. See, very good. Let's see, Q1 minus Q2 minus Q3. Beautiful guys, excellent. Full marks to you. Hats off. I should do this. Okay, very good. Let's get going to the next question. Let's see how many of you can do this. There is a charge placed at the center of a half a sphere, which is called as a hemisphere. Half a sphere. What is the flux through the curved surface of the hemisphere? What is the flux through that hemispherical surface? Come on, think about it. Very easy. Come on. Use Gauss's law. I'll just give you the hint. Come on, I'll just write Gauss's law. The total flux E dot dA, which is total flux through a closed surface, is Q in by epsilon naught. Come on, think about it. What is the answer? Some of you are saying B, some of you are saying, yeah, B only. Excellent, guys. If this was a complete sphere, then that enclosed charge is Q. So it will be Q by epsilon naught. But a sphere is made up of two hemispheres. So half the flux will go down, half the flux will go up. So each hemisphere will have Q by 2 epsilon naught. Yes, Q by 2 epsilon naught flux. That's how you can do this problem. Beautiful. Hello Janapriya, welcome aboard. Join in guys. All the new students, do not forget to smash the subscribe button, and all the existing warriors, do not forget to smash the like button down there. Yep, let's get going. So q by 2 epsilon naught, beautiful. Yes, very similar, Shivangi. We are going to come to Ampere's law also very soon. Let's do next question. Find the flux through the hemisphere, but this time the charge is outside. Come on, answer it. Come on, answer it. Come on, come on, come on, come on. The charge is outside the hemisphere. What is the flux passing through the hemisphere, guys? Think about it. Think, 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 think. Yes, 0. Beautiful. You can see it via diagram only. Whatever field lines will enter in, will exit also. Whatever comes in goes out. Whatever comes in goes out. Total is 0. So positive is negative. Negative is positive. So hence the answer is 0. Big fat 0. Yup. Let's get going to the next question coming up on your screen. Now, a point charge is placed at the center of a cube. Charge is placed exactly at the center, body center of a cube. Imagine the room, imagine the central point floating in air. What is the flux through any one face? What is the flux through any one face of it? Come on, think about it. What is the flux through any one face of it? Come on, come on, come on, come on, come on. Think, think, think. Oh, come on, my warriors. Figure it out quickly. Some of you are saying A, some of you are saying D. Come on, A or D? A for Apple, A for Ahmedabad, D for Delhi. Come on, or Dehradun. Yes, the answer is D. And the reason is the total flux through the cube, which is nothing but a closed surface, is Q by epsilon naught. The total flux going everywhere, here, 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 here. But a cube is made up of 6 surfaces. 6 surfaces. So through one surface, it will be Q by epsilon naught, 1/6 of it. Hence the answer is option D. Beautiful. Beautiful. That's how you need to solve it. Imagination. I hope you are loving these questions out here. These are strengthening your concepts. Yep. Now let's see how many of you can answer this question. Come on, come on, come on. Flux coming out and going in is given through this. What is the charge inside this surface? This is 30 which is going out, 20 going out, 25 coming in, 10 going out. What is the net charge inside this closed surface? Come on, think, 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 think. Come on, all my warriors. Beautiful questions coming up for all of you. Think about it very carefully. What is the net charge inside of it? Use Gauss's law. Believe me, there is nothing difficult in this. Come on, waiting for all your answers, my warriors. Come on, fight it out. Some of you are saying A. Asa Anand saying A. I'm not sure. Let's see. Let's see. Picture is blur. Arey, picture is blur. Come on. Please increase the resolution. Andrew says A. I don't know. Reggie says A. Priyanka says A. Okay. Yalni says A. Sai Sri also says A. Science Priya also saying A. Wondering. Okay. Let's see. Santosh also saying A. Come on, guys. I want you guys to change the logo also. If you have not yet changed your display picture, please download it. From the description box, there is a link where you can download the Warriors logo. Change your display picture. Show us your support. Well, I'll tell you what. The total flux is 30 plus 20 minus, because it's coming in, do not forget, minus 25 plus 10. Yes, that's what it is. This is minus 25. 30 plus 20, 50. 50 plus 10, 60. 60 minus 25, 35. So this is 35. And what is the total flux? It is charge inside by epsilon naught. So take this epsilon naught here. So aren't you going to get 35 epsilon naught? Yes, that's the answer. That's the answer. 35 epsilon naught. Beautiful. Based on Gauss's law. Be careful about the signs. The ones which go out is positive. Ones which comes in is negative. Let's see how many of you can answer this. Let's see how many of you can answer this. Come on, come on, come on. Think, think, think. Which of the following is correct for a charge which is inside a spherical surface but not at its center? Come on, think about it. So basically you have a spherical surface and the charge is not at the center. So this is the surface. Come on, think about it. Which of the following option is, or many options could be correct, I don't know. Let's see, figure it out. Which of the following option or options are correct or wrong? Come on, think. All my warriors, think about it quickly. Yep. Anjali says A, Nancy says A. Come on, Neha, Sai, Science Priya, Kumar, Minion Arti, come on, Reggie, come on, Village Rimar, come on, Yalini, come on, Pratik, come on, Jinesh, come on, Nilam, come on, Ram Prasad, come on, Santosh, come on, Guruvantra, come on, Kirito, come on, everyone, Andrew, yes, saying D, come on, everyone, let's see. Well, guys, the electric flux is positive for some part and negative for some part. How can that be? Because a positive charge will create field lines like this, right? Everywhere the flux is positive. Everywhere the flux is positive. Veba Singh, we are in the Pathfinder series. Today is session number 1. Already almost 1 hour, 5 minutes or 10 minutes are over of session 1. In case you are joining late, please watch the replay so that you can catch up for my next lecture. So the flux depends on the radius. What nonsense. As long as you are inside, the flux is the same. Total flux through the surface is 0. What nonsense. You can clearly see it is positive. There is no point where the surface has 0 flux. That is true. So option D is correct, guys. Understand that. Flux is there everywhere. The flux depends on the radius. No matter how big you draw the surface, the field lines will pierce them somewhere. So the flux remains the same. I hope this is clear. Everybody understand this? So that's why that is the correct answer. And it is not positive and negative. It is always positive for this situation. Yep. So no Khushbu, it's not A, it's D. Last question coming up for you guys. Last question. Come on, get ready. Charges Q1, Q2 lie inside and outside respectively of a closed surface. Come on, think about it. So there is a closed surface. Okay, there is a closed surface and charges Q1. There is Q1 here and Q2 over here. So if E is the field, S is the surface, phi is the flux, which of the following are correct? More than one may be correct. Let me tell you that. More than one may be correct. Come on, guys, think about it. Come on. Last question for today. And those of you who are in 10th standard, moving to 11th, me, Shivan sir and Abhishek sir will be going live simultaneously on 9-10 channel, Enthuse channel and 9-10 English channel, so that you guys get the next year plan and what should be the strategy, what are the lifestyle changes that are going to happen when you move from 10th to 11th. We are going to have a roundtable conference. We are going to tell you all the mistakes that we did, what should be done, what you should not do, how to choose a college, what should be the right mindset in this COVID situation. So if you have your friend, brother, neighbor, sister, any other relative who is in 10th and moving to 11th, please recommend them to watch the video live tonight after 15 minutes, on this channel itself or on 9-10 channel. All right, so do that. Okay, so guys, I'll tell you what the answer is. Some of you are saying AD, some of you are saying AC. Well, actually, if Q1 changes, obviously, if Q1 changes, field and flux will change. Makes sense. That is because of Gauss's law. That is because of net flux is Q1, which is Q1 by epsilon naught. And net flux is obviously cyclic integral E dot dA. Okay, so if Q1 changes, the flux will also change, the field will also change because the number of lines coming out of it will change. Obviously, this is correct. Obviously, if Q2 changes, E will change, but flux will not change. Now, this is very important. If charge 2 changes, it will not affect the flux. Correct. It will not affect the flux, but the field will change everywhere. Think about it. Chandan, you can contact me on Shreyas_Vedantu. That's my Instagram handle. I don't share my mobile number. Okay, so basically, guys, field will change because if you take any point, the field will be because of Q1 and because of Q2, both. Understand? So both of them will create the net field. So the net field will change because of both of them. Okay, so that is very important. This part depends on both inside and outside charges, but the value of the complete integral only depends on the charges which are inside. That's the conceptual question. If inside charge is 0, this is the inside charge, and outside charge is not 0, then field will not be 0. Obviously, if inside charge is 0, outside charge is not 0, the field will still be there because of outside charge. But the flux will also not be 0. Okay, now this is interesting. The flux will not be 0. Guys, think about it. What do you guys say? If there is no charge inside, okay, if there is no charge inside, then the net flux will have to be 0. The net flux will have to be 0. So option C is wrong. Okay, option B was correct. The last one, if there is a charge inside but there is no charge outside, then E is 0. Is the field 0? No, the field is not 0, but flux is not 0. So option D is also wrong. In fact, field will also not be 0 because the field will still be there because of charge 1. Yep. So only A and B are correct. Yep, only A and B are correct. Correct, guys. Okay. So this is your homework question. This is your homework question. Try to solve this. Post the answers in the comment section below. And remember, the answer for this homework question will be only coming up in the Telegram group. So do not forget to join the Telegram group. The link is shared in the description box below. Answers will be coming up over there. And remember guys, those of you who are planning to join the long-term courses, the option is still available. Remember, there are 3 kinds of options available for both of you who want to study online. So with all the tests, live coaching, all the long-term batches, micro courses, assignments, Tattva module, Hindi English batches with master teachers like me. In fact, I'm also teaching in the toppers batch, like you know. So there are 3 options. Light version is when you want everything, but you don't want a personal teacher, or you're okay with not having doubts. Okay, that's the option you have. Second option, you want the doubt solving. If you want the doubt solving, then you go for the classic version. If you want personal mentor, then you go for the plus version, the pro plus, that includes everything plus the personal teacher. Now all these prices you get it at a discounted rate, like you see over here. So the actual price is a lot more than what you get over here by using the coupon code SHHPRO. So if you want to study under me, Shimon sir, Wasim sir and teachers like us, do not forget to enter into the subscription. You can get a variety of teachers, choose the courses, all for free once you join in. Thank you guys for tuning in. See you again next week for the Pathfinder series. So we are going to continue with Gauss's law. Gauss's law is not yet over. We are going to have a lot more problems, applications, etc. next week. So stay tuned. Thank you for joining in. Do not forget to hit the subscribe and the like button out there. Bye bye guys. This was Captain Shreyas. Hasta la vista. Take care.